Hi, I'm Robert Curtis. I'm the head instructor of the Distance Calculus program. In this video, I'm going to talk about the Differential Equations course. Differential Equations is usually taken as a sophomore, and it is after the Calculus 2 course. So you need to have completed Calculus 1 and Calculus 2 in order to meet the prerequisites for differential equations. Now, assuming that you have those prerequisites, and you should know if you do or not, you need to have the skills of both differential and integral calculus and series and power functions to be able to engage the differential equations course. The curriculum that we use is called Differential Equations and Mathematica. Now, in our lower courses, we use the live math software because it's it's in between a graphing calculator and the more powerful Mathematica software. Mathematica is extremely powerful. In the Differential Equations course, which is a second-year course, or in some universities is even a third-year course, the software that we use is the Mathematica software. Now, how does this course differ from other differential equations courses, other than the way all of our courses work with our recursive grading and mastery learning format? How does the curriculum really differ from from other differential equations courses? Well, there are two kinds of curriculum in differential equations. There's classical and there's modern. Classical is actually the course that I took when I was a student. This was 30 years ago. And it is the classical course is on hand calculations. To solve differential equations. When you're presented with a differential equation like 5y double prime plus 3y prime plus y equals 6 sine of x. This is a differential equation, and this is actually a function. It's y. We write it as y, but what we really mean is a function. Written in function notation, it would be 5f double prime of x plus 3 times f prime of x plus f of x equals 6x, 6 sine of x. And you're solving for that function now. The classical approach to this course is to learn all of the hand calculations for solving differential equations that were developed over the last 2 centuries. And certainly in the 1800s and the 1900s of how to solve this without a computer. And you can. There are techniques for solving this equation. Just can't leave it hanging there. I got to put the right-hand side, the non-homogeneous part. And there are hand calculations for solving these kinds of differential equations by hand. So if you're ever stuck on a deserted island with no computer and you want to solve this differential equation, you can do it. All right? And there are recipe books for how to deal with this differential equation when it comes up and how to solve it. And all of the techniques have names, variation of parameters, integration factors, and you are presented with a differential equation, and you are asked to apply one of those recipes for solving that differential equation by hand, and there you go. That's the differential equation course that I took when I was a student. And if you've ever taken differential equations as well, that may be the course that you took as well. Maybe you finished it, maybe you didn't finish it, maybe you just need to take it again, for whatever reason. One of the authors of the calculus, the differential equations and Mathematica course, Bill Davis, said, I believe in the textbook somewhere, but I know he said it to me personally, this is not your parents' differential equations course. And this textbook in quotations, is almost 40 years old now, and it is definitely not the course that your parents took. It's not the course that I took either. It is absolutely a modern course on differential equations. Now, that has its pluses and its minuses. If you are a math major and you are, and I'm really only talking about pure math majors right now. If you are a pure math major and you're looking to take differential equations course from us, you should absolutely check with your department to make sure that doing a modern differential equations course is going to be okay for you. Many math departments that are pure math departments, solid pure mathematics departments, and if you're doing a pure math degree, they will discourage you from taking this modern course. They want you to take the classical differential equations course. Why? Because, somehow that is pure mathematics, is to be able to do, to investigate differential equations from a classical point of view and solve those equations by hand. I understand if you're a pure math major, they're getting you ready for higher courses like abstract algebra, like real analysis, and you have to have these hand techniques, in your toolbox up here to be able to go forward in a pure math degree. So some departments are discouraging of our curriculum, and you should check with your department if you are a pure math major. If you are an applied math major, or physics, engineering, etc., any of the sciences, economics, if you are anything but a pure mathematics major, then you're going to love the modern approach. You're going to love it. Because instead of spending hours and hours and hours on how to solve these equations that I've now erased by hand, you are going to study these equations from an analytical point of view. You are going to use Mathematica as an experimental tool, and you're going to act like you're in a laboratory, and you're going to study those equations like I wrote, which I'll write again, 5y prime plus 3y double prime plus 3y prime plus, what did I have here, plus y equals 6 sine of x. You are going to study these equations from an analytical point of view using Mathematica as your microscope, as the tool in the laboratory to study these equations. Because Mathematica has this thing in it called dsolve. And when you put this equation into dsolve in Mathematica, it gives you those solutions. Bam! That is a modern approach. We have modern tools for studying these differential equations, and dsolve allows for the doing everything and better that all of your classical training in solving differential equations manually has. It's all built into dsolve. And it is, of course, faster, error-free, and it knows way more differential equation solving routines than you will ever do in your entire lifetime. There are dozens of programmers, if not hundreds of programmers, who have invested time in this function called dsolve to be able to solve basically any differential equation you hand it, and it will give you out the functions that satisfy this equation. The important part of a modern approach to differential equations is, what do those functions mean? How do they, what is it they tell you about what's going on? What is this part of the equation telling you? What's the graph of these functions telling you? This is called a driving term. That's the way the engineers think about these equations. You put a driver on it. What does that mean? Well, we're going to look at it, and by using a tool like Mathematica, you're able to put different functions in here and look at how putting different functions in the driving term changes the solution graphs of what's coming out. And then you understand, oh, the driving term affects this, and this is the homogeneous part of the equation, and the solutions look like this for the homogeneous term. It's fantastic to understand how these equations operate in terms of, their graphs, their analysis, what they're telling you. If you're a physics or economics major, or engineer, you're going to love this, because it is not about the boring solution recipes of classical approach to differential equations. It is the modern approach of analyzing those differential equations, finding out what they're telling you, and seeing how when you change functions over here, the driving term, how does that change what's going on with the solutions of the equations? It's really wonderful. Now, having said that, this is a modern approach. I keep using a lot of engineering and physics. There are a lot of applications in this book, but I wouldn't say it's an application-centered curriculum. It's still very mathematical and extremely analytical to get at how these differential equations and their solutions should be analyzed. But you will see a lot of topics from physics, topics from engineering that come in and are used, and I think in a very brilliant way. This is one of the best books out of the series, the best curriculum out of the series of Calculus and Mathematica. And it's just a wonderful, wonderful course. It's a very long course. There are, I believe, 11 modules total. And each module has a lot of stuff in it. So it is a very, very long course, very thorough course. When you come out of this modern differential equations course, although you will not be as powerful as a classically trained differential equation solver, you will have you'll have a superior knowledge of differential equations. You will understand differential equations way better than a student who has been classically trained. Although, if you are stuck on a desert island without a computer and without Mathematica, and there is a contest for food, based on how well you can solve differential equations by hand, you will lose. So just keep that in mind in case you're planning to be deserted on a desert island and your companion may be a classically trained differential equation solver. You will lose that battle. But in any other application of differential equations in industry, this will be extremely powerful to you as part of your career toolkit. And we've gotten, thousands of students have gone through this curriculum, and tens of thousands in the curriculum in general at all the schools. But in our program, I would say we've probably had 500 differential equation students, and almost all of them write just such glowing reviews after the course when they go on into their career, and they'll write me a year or two or three down the road and they'll say, wow, I can't believe how much I use this stuff. It is so fantastic. I totally understand what we're doing. And my colleagues who took the classical differential equations, they're not really keeping up with me. I'm running circles around them. And of course, in a career, it's always nice to run circles around your colleagues, because that probably means you're going to get promoted and get a raise. Now, I want to stress once again that if you are a pure math student, a pure math major, you probably will be asked by your department to take a classical differential equations course, and that is not this course. So please double check with your department to make sure that they do not have a restriction like that on you. You do need to be pretty good at Calculus 2. And there is no review in this course for differential equations. and Mathematica. We start right with differential equations, and you better remember what a derivative is, you better remember what an integral is, and you better be pretty good at it too. If you are weaker in your Calculus 2, I can give you some review assignments to do to prepare a little bit, especially if you've been away from things. But in general, the course does not have any review built into it. And I wouldn't say that it's difficult right out of the bat. I would say the second and third module gets to be pretty challenging, and then it streamlines to the end. Students have difficulty in the second and third module, and then they find their stride, and they do really well through the end of the course. So review of Calculus 2, we can add in, but you should, if you haven't taken Calculus 2 in a while, like if you're one of the students, like I took Calculus 2 20 years ago in college, you may wish to repeat Calculus 2. All right, that may be something. I usually don't recommend students retake a prerequisite course that they finished, but in this case, sometimes I do. You do not have to take multivariable calculus before this course. In fact, multivariable calculus has nothing to do with differential equations. And likewise, linear algebra, you could take linear algebra. Many students take differential equations and linear algebra concurrently, together, which is a nice pairing. They're very different mathematically, so when you get tired in one class, you can go to the other curriculum and it doesn't feel like it's just more of the same. It works different parts of your brain in some sense. So it's a nice dual kind of course to do, and both have Calculus 2 as a prerequisite. There are not very many videos for the Differential Equations and Mathematica course. I've made some for the first module to help students get going, and I think maybe some for the second. And for some difficult notebooks throughout the course, I have made some discussion videos to try to help students. But at this point, we're talking to sophomores who have had some success in calculus already, and I haven't made an extensive video library for this course because it doesn't seem to be really necessary. I've made some for some particularly hard discussions. Students who have asked me, could you make a video for this module? I really don't get it. And there's probably maybe 15 or 20 videos for this curriculum that I've made, and they've all been made because a particular student asked for a particular topic to be presented in video format to help them. But in general, this is more experimentation using Mathematica, and that's really your tutor in the course. You throw it at Mathematica, you get out some solutions, and then you analyze it. A lot of writing in this course, once again. Mathematica is a more challenging computer program. Students who are not as good with technology, not as good with their computers, this is a more challenging course. For the technology, Mathematica is not as easy to use as live math, and so your skills will either get better or you'll need some help getting your technology skills up to the level necessary. But most students, I've found, do very, very well with that aspect, and they move in from live math to Mathematica rather seamlessly. It's almost like the first year of calculus you use live math and you kind of get to the edge of its usefulness, and then you're ready for something more powerful, and it's kind of like changing gears on your sports car, and it's like, now I'm going to go into turbo, and Mathematica is definitely turbo for differential equations, and I think you'll really enjoy it. It's a fun class, it's a very exciting class, and actually getting through all 11 modules of differential equations, you actually bridge into what's called a senior level course in differential equations or partial differential equations. It's called usually ordinary differential equations, which is the same name as the lower sophomore course, but it really bridges into like the senior level of dynamic systems and studying those topics. So it really bridges far beyond the classical set of differential equations topics. So it's a very wide course indeed. All right, if you have any other questions, please email me those questions or chat with me, and I'll try to answer them as you present them. We'll see you soon.